In this example, I'm going to show you how to use Wilcoxon rank sum test. Wilcoxon rank sum test is a non-parametric test, and we use that when the normality assumption is not valid. So the assumption for this test is as follows. First one is the two samples are independent. So independent samples are crucial. So the second assumption is even though they are not normal, the populations, we still assume that they are identical to each other with some shift. So two population have identical distribution with shift. So what that means is, so let's say your population 1 is look like this. Okay, look, it's not normal, and then the assumption is the second population is something, it should be look like this. So there's some shift, but they look they have the identical distributions even though they are not normal. So once these are satisfied, you can use Wilcoxon rank sum test. Now look, with this kind of distribution, the skew to the right, this kind of distribution, you cannot use usual t-test to uh, test for the inference for the mu1 minus mu2 for the difference between two population means. So how you get any kind of inference if you have a distribution like this? The idea is use Wilcoxon rank sum test. So that's what we are going to here. So the first thing is when you do this kind of test is you have to follow a few steps. So first list the data value for both samples from smallest to largest, then assign ranks, and then you calculate the sum of the rank from population 1. So that's what we are going to do. Okay. So let's calculate the rank. So I'm going to when you calculate this rank, you have to pull the entire data set. So you have this data set and list in increase in order. So I get this 16 first, that's the smallest one. So I have 16, then 25, then 63, then 68, then 84, next 103, next 122, and then next 305. Okay, so now you can assign the rank. Okay, so what's going to be rank? This one is going to be first, second, third, fourth, fifth, sixth, seventh, eighth. Okay, now still you have to keep a record where these dates are coming from. So this one is my this one is coming from men, and 25 is coming from women. Then the 63 is coming from men, 68 is coming from men, 84 is coming from women, 103 is coming from women, 122 is coming from men, 305 is coming from men. Okay. Let me see whether I made a mistake. 1, 2, 3. Where did I miss one? Oh, 63 is coming from women. So this one here is I made a mistake. So it should be women. Okay. So now the next step is let's write down the hypothesis. So I have H naught. What do I want to prove? I want to prove that men download more movies onto their computer. So more. So this means mu men, the H naught is they are same. H A alternative hypothesis is going to be mu M is more than mu W. Okay, so I have these two hypotheses. So now find the rank sum. So calculate rank sum for first population. So in this case, my first population is what? It's going to be this side. Okay, so it's going to be for men. Okay, so when I calculate the rank sum, it's going to be look like what? Let's use T. Tm, that's going to be I have to add 1, then I have to add 4, then I have to add 7, then finally I have to add 8. So my rank sum is 20. Okay, so once you have rank sum, you can calculate the critical values. Okay, so calculate critical value. Second step. Now, how do you calculate critical value? Because we are not associating this with any kind of distribution. Now, to calculate critical values, you have to use tables given in the textbook. So, if you go to textbook, you will see this kind of table, table 5. Okay. So, in here you can see that critical values. So, let's say we are using alpha equal 0.025. Okay. Let's make assumption. Assume alpha equal 0.025, and this is one tail test. Okay, it's not assumption, it's from this hypothesis. You can see from here this one is actually what? It's right tail test, so it's one tail. Okay, so now if you go back to the tables, what is our sample size? Let's look at that too, because we need sample size. So my N1 for men's, how many did I have? 1, 2, 3, 4. Sample size is 4, and for the women, sample size is 4. Okay. So now let's go back to the table. In this table, so I need alpha equal 0.025 for one tail. That's what I'm using, this table. And the N1 and N2. So N1 is the size of first population, or for men. N2 is the size for second population, or for women. So I need 4 and 4. So what is the value? It's going to be, because it's upper tail, it's 25. That's the critical value, 25. 4, 4, they meet at 25. Upper tail. Okay. So I use the critical value now. So I have TU, or critical value for upper tail test. When N1 equal 4, N2 equal 4, and alpha equal 0.025, that's going to be what? Is 20. What did you get? I think it's 25. Okay. So so you have this critical value. Now you have to decide. You have to make a decision whether you are going to reject or fail to reject. So the idea is here is the decision rules. If you are using left tail, right tail test, and if T is more than TU, then you reject H naught. If it is not more than TU, then you fail to reject H naught. So I'll write here, since Tm, or my test statistic, which is actually 20, is less than TU, which is 25, we fail to reject H naught, or we can say we do not have enough evidence claim there is significant difference between average for two population. Okay, that's how you do the Wilcoxon rank sum test. So next, what we are going to do, we are going to use the normal approximation for Wilcoxon rank sum test. In the next video, you can see that.